So here we have two vectors. Vector A is 6, negative 2, and B is negative 4, 4. The vertical component, or the horizontal component for A is 6, and the vertical component is negative 2. And then for B, horizontal is negative 4, and vertical is positive 4. So a little bit of a review: if you're going to graph vector A, you would go 6 out in the horizontal direction and then 2 down in the vertical direction, which would be right there. So the vector would go from 0 to that point. For vector B, you would go negative 4 in the horizontal direction and then up 4, which is about right there. And then the vector would go to that point. And we want to think about what would happen if you were to add these two vectors together. Would you get a new vector itself? So if we're going to take vector A and add vector B, what would that give us? So since both of these have horizontal components and then vertical components, what you're going to do is you're going to add the horizontal components together. So that'd be 6 plus negative 4. Which is 2. And then you're going to add the vertical components together. Negative 2 plus 4 is also 2. So when you add two vectors together, your answer is another vector. All right, it has length and it has direction, just like the other ones do. If you're going to think about this on a graph, if you think about how vector A is going to go out 6 and down 2. If we want to add vector B to it, we're going to start at that same place, and then we're going to follow the directions for vector B. We're going to go backwards 4 and then up 4. So we're going to start here and go back 4 and up 4. And that ends at this space right here. At the space 2, 2. We'll see. So if I draw vector B, I would go back 4 and up 4. That'd be here. Remember that this vector B is the same as this vector B. Vectors only have to have the same direction and length. They don't have to be in the same spot on the graph. As long as they're pointing in the same direction and have the same length, they're considered the same vectors. They're considered congruent vectors. So if we start B where A ends, then the point where B ends will be the sum of those two vectors. And you could do it the other way. You could start where B ends and follow the directions for A. So if we start here at negative 4, 4, and we go positive 6 in the horizontal direction for A, and then down 2 in the vertical direction, then we would end up in that same place as well. So this is vector A, this is vector B, and this one right here is vector A plus B. So adding vectors, remember when you do it algebraically, all you do is add the horizontal components together and then add the vertical components together. Subtracting vectors works very similarly. Whenever you subtract vectors, each vector has a horizontal component, and so if you do vector C minus vector D, remember with addition, it doesn't matter what order you add things in. Subtraction, it does matter. You always have to do the first one minus the second one. So when we do C minus D, we'll be doing 5, so the horizontal component of C, 5, minus negative 2. And remember when you do 5 minus negative 2, turns into adding, so we'll have 7 for that horizontal component. And then we'll do the same thing with the vertical components. The vertical components are 3 minus 6. So 3 takes 6 steps backwards, that ends at negative 3. All right, so vector C minus vector D is 7 comma negative 3. And we can do this algebraically just like before. So if we look at vector C, we'll go out 5 in the horizontal direction and then up 3 in the vertical. So that would be here. And then if we look at vector D, we go backwards 2 in the horizontal and up 6, which would be there. All right. Now, when we subtract, instead of putting D in the starting place and going that direction, that would be adding, right? Since we're subtracting, we're actually going to be going the opposite of both of these. All right, so we can think of the opposite of D as being the opposite of negative 2 and the opposite of 6. All right, so instead of going that direction, we're going to go the exact opposite direction. So we're going to go out 2 in the horizontal and down 6. Let's see, 1, 2, 3, 4, 5, 6. That'd be right there. So again, our answer vector C minus D will start where the first one starts and end where the last one ends, which is 7, negative 3. This point right here is 7, negative 3. So one way that you can think about subtraction is just adding the opposites. So 5 and the opposite of negative 2. So I'm going to add 5 and the opposite. And then I'm going to add 3 and the opposite of 6. And that also means opposite in direction when you're doing it geometrically.